2, right? Let me see. Okay. Right, that's the half there. Okay, yeah. So I think this should be our final expression. Then again, you are welcome to go through the exercise again and see if we did not make any mistakes. But it doesn't seem as if we did, right? So that should be the correct final answer. But now, as you can see, it takes quite a lot of calculations, right? Even the method that we use, right, which officially starts here. So we initially used, right, integration by parts, and we just kept using it, right? So that was the first time. So we used it once. Then we used U substitution, right? So then the second integration by parts and the third one. So 3 integration by parts and 1 U substitution, right? All of that to end up with this solution. Right? But as you can see, it takes quite a lot of space, right? So normally what I would suggest is, well, we'll get back to this one just now, but let's skip that one for now. So what I would suggest is instead use U substitution right at the beginning. So remember the question is, right? So the question is find the integral of sine of the square root of x dx. So try using U substitution first. So use root x there. Then you have du is equal to 1 over 2 root x dx, right? So then bring it back to the expression, you would have sine of u, right? Multiplied by dx, which will just be 2 root x du, right? Which will give you, we know that u is root x, so this will give you just 2u sine u du, right? Which is easily use which integration by parts is easily implemented here to find the solution to this. In fact, I've already done that for, yeah, there you go. So using integration by parts at that stage, you would get this final answer already there, right? So you would have already negative 2u, right, cos u plus 2 sine u, if I'm not mistaken, right? And we know that we substituted root x to be u, so that would be negative 2 root x cos, right, cos of root x plus 2 sine of root x. And there you go, right? Look how small this is, right? Oh, rather, well, to be honest, it's not that small because we have already calculated the integration by parts for this integral. But then it would just be a few more lines, right, of calculations. But now compare it to what we did before. As you can see, one method is quite fast, right, compared to the other one. So that should tell you that in that case, it would have made more sense to start with u substitution at the beginning to get rid of that square root, so that you would be able to use integration by parts then, right? So that's the sort of combination that you would have to make there. Hopefully that makes sense. Any questions? Any questions at all? You're more than welcome to ask.
Excuse me, sir.
Yeah.
In the first method, there is a part where you... Where is this part?
Let me scroll down. Just tell me when I can stop.
All right, I'm looking for it now. Okay, it was soon after you used the first integration by parts.
Right, this one.
That's the step, yes, the second step.
This
where
step
you have
you're speaking about here.
wait,
Or
you
is it
have
here?
substitute, no, the other one where you canceled out your root x, I think.
Oh, yes. Your x with the root x.
Can you please explain that step, how it leads to the following step?
Oh, you mean how I went from this here to that?
Yes, please.
Okay, no problem. Let me do that. So we have the first part here. So I'll use integration by parts. Substitution tells us that we're choosing u to be sine root x and dv to be dx. So that means v is x and du is just the derivative of sine root x, which is, using chain rule, the derivative of the outside function, right? So that's cos, from sine to cos root x, multiplied by the derivative of the inside function, which is the derivative of the square root of x, which gives us 1 over 2 root x, right? So that's up to that, multiplied by dx. So now we have to implement the integration by parts rules. So it tells us that we have to multiply u by v. So u, which is our sine root x, by v, which is x. So x times sine root x, right? Minus the integral of v du. So x times du, which is 1 over 2 root x, right? So that would be x over 2 root x multiplied by cos of the square root of x dx. Right? So that's up to there. But now we know that x is just the same as the square root of x squared. Right? So we know that. So when you have x divided by the square root of x, it's basically just the same as the square root of x squared divided by the square root of x. So you can cancel those two. And then you would be left with 1 square root of x in the numerator and 1 in the denominator, right? So that just 1. So that would mean you'd be left with the square root of x divided by 2 alone, right? So now, since you have the square root of x divided by 2, you can take out this 1 over 2, which is the constant. So that would be 1 over 2 just multiplied by the square root of x. And this 1 over 2 is the one that we took outside the integration function there. And then we left the root x inside. And then the cos part is the same. Does that make sense? No.
Yes, thank you very much. Thank you.
No problem. Right. So any other questions for this? Okay, hopefully this makes sense. Moving on. Let me erase this. So we can move on to the next problem. Right. So the next problem is asking us to find the integral of x cubed times e to the x squared dx. question for you. What should we do? What should be the first step here in solving this?
So
Right, go ahead. I'm sorry, go ahead.
okay,
One at a time. It's okay. Sanele, you can go ahead first, maybe.
okay. I think we should let x squared be equal to u.
X squared be equal to u. So we're using u substitution, not is it integration by parts or u substitution?
U substitution first.
Okay. Right. The other person, please, you can speak now if you don't mind.
I was also suggesting the same.
Oh,
U
the same,
substitution.
right? U substitution. Okay, thank you. So let's try that. So using u substitution, we are letting our u be equal to x squared, right? So if you do that, then you have du equal to 2x dx. Please mute yourselves if you are not asking the question, so there's no background noise. So 2x dx, right? So that would mean that now our original expression is becoming, we have x cubed, right? So x cubed can be broken down into right, x cubed can be broken down into x squared, right, times x. And that x squared is u. So we have u times x, right, times e to the u dx, which is just equal to du divided by 2x. So the x here can cancel, right? And 1/2 here can come out of the integration to be 1/2 multiplied into the integration of u times e to the u du, right? So at this point here, what method should we use to solve that? We have the product of two functions. What should we use?
Integration by parts.
All right, so let's try that. Using integration by parts now, what should be our, let's call it f, and what should be our dg?
Let's f be u and dg be e raised to u.
Right, so let's try that. Let's f be u, let's dg be equal to e to the u du. So now our df will be du, right? Our g will just be e to the u, because you know that the integral of e to the u is just e to the u, right? So the formula tells us that we would have f times g minus g times df, right? So that would mean u times e to the u minus the integral of g df, which is e to the u times du, right? Which is equal to u times e to the u minus the integral of e to the u, which is just e to the u, right? So now that we have that, we can bring it back to the expression there, multiply this thing by 1/2, right? So our original expression, which was x cubed times e to the x squared dx, is therefore equal to 1/2 multiplied into this. So we substituted u by with right, so x squared. So we would have x squared times e to the x squared, right, minus e to the x squared. Right. Hopefully this makes sense, which we can try to simplify further to be x squared over 2 multiplied into oh, sorry, no. 1/2 multiplied into not 1/2, that would be e to the x squared multiplied into x squared minus 1. There you go. So that should be the final form. Any questions? This one was a pretty straightforward and quick one. Of course, now someone might have chosen to use integration by parts right at the beginning, right? Which doesn't make it wrong, but you would, in fact, as homework, I want you guys to attempt this. So as homework, try to attempt using U substitution at the beginning, right? So try using, right, so dv. So which U substitution you could suggest? Well, we could try U equal to x cubed and dv be equal to e to the 2 to the x squared dx. So I want you guys to attempt this and keep going. See how long it takes you to get to the final answer, because you already know what the final answer looks like. So if you, whatever your calculations here get you that is not the same as this one, then you know there's a mistake somewhere, right? So I want you guys to attempt it as homework and let me know how it works out, right? So, all right, any questions here for this question, for this particular problem? All right, I'll take your silence as the fact that means there's no questions. Okay, so the next one that we have now is asking us to find the integral of the integral of sine 8t times cos of 3t. So now, what method do you think we should use here? Hello?
Can we use a U substitution? Let cos 3x be cos u. 3
Right, sorry, U substitution. So let's cos 3x be equal to, sorry? U. So is that what you meant?
Wow. Right.
So I couldn't hear you correctly there. So if you do it, sorry, go ahead.
I was saying yes, sir.
Right. So if you do it this way, let's try to see what it gets us. So you would have du is equal to -3 sine 3t dt. Right. So, and as you can see, this is pretty much as far as you can get because you have sine 3t there and sine 8t. So you can't even cancel that. Right. So for these types of problems, if you remember correctly in your in the first semester, we used to use for this one, we used to use what is it called? We used to use the products to sum formulas, right? You remember those formulas that gave you, for example, when you have sine of x times sine of y, that is just equal to 1/2 times cos of cos of y minus x minus cos of x plus y. Remember those formulas and whatever the rest was, right? So you had a bunch of these formulas, and basically what you're trying to do is get away from this product to a sum or a difference that you could easily integrate, because that would mean you just separate these integrals into two, right? And you know how to integrate cos functions and sine functions separately. So that's how you would do it in that semester. But now, since we already have another tool, right? We have a tool that we can use, which is integration by parts, right? So we have integration by parts in our toolbox this semester. And I'm asking you now, what do you think we could use as our U and our DG in this case? Oh, sorry, not DG, but this should be DV. What should be our U and our DV? Keeping the integration by parts mindset, because that's the whole purpose of the worksheets, practicing integration by parts. So keeping that in mind, what do you think we can use as our U and our DV? Well, I'll suggest something since everyone is quiet for the sake of time. So we could use, for example, that our U is equal to sine 8t, and that our dv is equal to cos 3t dt. So let's see if it works. That would mean that our du is equal to 8 cos 8t dt, and our v is minus 3 sine, oh, right, not minus 3, so that would be just 3 sine 3t, right? Oh, sorry. That would not be 3 sine dt, that would be sine 3t over 3. Right. So now, using that in mind, we would have this equal to our u times v minus v du. And our u times t is just sine 8t times sine 3t over 3 minus v du, which is sine 3t over 3 times 8 cos 8t dt. We can take out the 8 over 3 as a constant out, so we have sine 8t sine 3t all divided by 3 minus 8 over 3 multiplied by the integral of sine 3t cos 8t dt. To stay consistent, we'll have to let our u again, right? Because we have to solve this integral by integration by parts. We have to let our u be equal to the sine function, right? So the sine function is, in this case, 3t. And our cosine function is dv being equal to cos 8t dt. Our du now will be 3 cos 3t, and our v will be just sine 8t divided by 8, which means that this integral will become, u times v. So u times v, that would be sine 3t times sine 8t all divided by 8 minus v du, which is the integral of sine 8t divided by 8 multiplied by 3 cos 3t times dt. Once again, we can take out the 3 over 8 out. So you have sine 3t sine 8t all over 8 minus 3 over 8 times the integral of sine 8t cos 3t dt, which, if I'm not mistaken, this is the same as our original function, right? Which you guys can find up here, right? So that means that the original function, which was the integral of sine 8, yes.
So how do I know that to give you sine or cos? How do I know which one to assign to you?
Oh, right. So as the first, so if you go back to our first substitution in the integration by parts, I could have used here as our u, because as you can see, sine and cos are easily you can easily integrate them and find their derivative. So for this particular example, you have the choice to use u as our sine function or u as our cos function. So you could use either ones. So for example, I could have used, instead of sine, letting u be equal to sine 8t, you could use sine equal to 3t. Sorry, u be equal to 3t, and then your dv will be just sine 8t dt. You would follow the same procedure. But now, remember, if you use that substitution, then it means that when you come to your second integration by parts, you'd have to use the same consistent substitution. So as you can see, the first substitution, I used the u to be the sine function. So the second substitution has to be the same. U has to be the sine function again. Our dv has to be the cos function, right? So if you flip it, the first substitution would be our cos function, and for the u, and our dv will be our sine function, meaning our second substitution will have to, u substitution will have to be the cos function, and our second dv substitution will have to be the sine function. So you have to stay consistent, right? Because for this particular example, you have the choice. You could use either ones.
All right, thank you.
Yeah. So the original integral, which was sine 8t times cos 3t, we found to be equal to the first part here, which was sine 8t, I think sine 3t divided by what? Divided by 3 minus 8 over 3, right? So 8 over 3 times that entire integral, which we just found to be this thing. So 8 over 3 multiplied by sine of 3t times sine of 8t, all divided by 8, minus 3 over 8 multiplied into the integral of sine of 8t cos of 3t dt. As you can see, this 8 over 3 is going to cancel with that one when you multiply it in. So this will be sine of 8t sine of 3t divided by 3 multiplied into minus, this will cancel there. So you have minus sine of 3t sine of 8t divided by 3 plus, this cancels, so basically the integral of sine sorry, just give me a minute. There's a sign mistake somewhere. Let me just go through the calculation again. U times V times that minus v du, which is v du. So that would be sine 3 over 3, sorry, sine 3t over 3 multiplied by du, which is 8 cos 8t dt. Okay, so this is correct. Then the next step, you take out the 8 over 3. You're left with the integral of sine 3t times cos 8t, which will give you, keeping the same consistent substitution, u is equal to sine 8t, in this case sine 3t, then the du would be 3 cos 3t, dv is cos 8t, so that would mean v is equal to sine 8t over 3 over 8. U times v is sine 3t times sine 8t over 8, so correct, minus v du, which is just sine 8t over 8 times du, which is 3 cos 3t dt, so this is correct. And then the next will be 3 over 8 will come out. You have this integral here, which is the same as that one there. Okay. So then we would have, oh, still there's a mistake somewhere. Right, in the interest
Sorry,
of,
sir.
yeah, go ahead.
V shouldn't be negative sine 3t over 3 on the third.
Right, where is it? Oh, is it here?
V on the top shouldn't be negative.
Where, which v? Which one? Is it here?
The first one,
This
V
one?
equals negative sine 3t over 3.
No, because we're doing the integral. The integral of the integral yeah, the integral of course is sine, right? Sine, but the derivative of course is negative sine. So here we are looking for the integral. So this is correct here. Because when you derive sine 3t over 3, you have cos 3t. So it seems as if we made a mistake somewhere. Right, so I think, as I will suggest that in the interest of time, since we're already running past the time, I want you guys to attempt this, right? So attempt this problem, go through the calculations again, right? And see if we made where we made a mistake, because as you can see, this is going to cancel, right? And then you will be left here with sine 8t cos 3t dt, which is just basically the same as there. So we are just going back to the original question. We are not actually solving the problem. So what I would suggest is, I don't know where we made a mistake, but just go through the calculations again, right? In your own time as an exercise. Try to figure out if we made a mistake somewhere. If we didn't, try to flip the substitution. So try to use u to be cos of 3t and try to use dv as sine of 8t dt and see if it gets you to the final answer, right? So try that and then see if it gets you to the answer. I will also try to attempt it on my own, and then maybe I'll upload the recording as a separate recording for this particular exercise. Yeah, I think that's what we'll do. Right. So, anyways, thank you for attending. I will see you guys next week. Now that will be in person. Let me just stop recording.